Hello everyone. In this video, we will talk about bitwise operator, right? So in the previous video, when we discussed about logical operators, I just showed you some difference between bitwise and logical operators, guys. Like if we consider bitwise operators, in case of AND operator, we'll have to take one AND sign, and if you want to take logical AND, you have to take two AND sign, guys, right? So if I show you my screen, I'm going to show you a program in my screen. Here we have a uh, a variable has a value 5 and b variable has a value 3. Okay, and now we are assigning a and b in result a variable, right? So this is a bitwise operator, guys. So why do you need a bitwise operator, guys? I just want to explain this to you in short, right? You know, in an integer variable, we have 4 bytes of space, right? 4 bytes of data. Okay, it will take 4 bytes in memory. So sometimes, you know we may you know we may not use you may not need all the space of 4 bytes, right? 4 bytes mean 32 bits, guys. 1 byte is 8 bit of data, right? 8-bit space. So we may not need 32 bits. Okay, so we may use the unused bits. We may need it, or you may use. Okay, so these types of operations are really complicated things and are used in highly complex, or it's in like a very good softwares, right? Softwares are really sophisticated. Softwares need this kind of operations, guys, like operating systems, or maybe. So as a very beginner programmer, or maybe not all of us will work in these big companies for sure. Okay, but we will just take some simple ideas, guys, about these things. It will help us that and we will be satisfied that we know. And who knows, maybe some of you will work there. Nobody knows, guys. uh, anyway, so we have 5 and 3. Okay, so a and b, this is bitwise operator, bitwise AND, guys. Okay, so what's the result? If I show you the result, you will see it's 1. So how actually it works? Okay, so here I'm just showing you how actually it works. Binary of 5 is 0101, right? Binary of 3 is 0101. So if I show you here. Okay, so first of all, we will see how binary of 5 is calculated, right? So if we divide, we know the binary is only two numbers, 0 and 1, right? So we will divide 5 by 2. Okay, so 2 will be the result and we will have 1 as a remainder, right? And if we divide the result 2 by 2 again, we will have 1 as a result and remainder would be 0, right? And if we divide 1 by 2 again, so 0 would be the remainder and 1 would be the 0 would be the result and 1 would be the remainder, guys, right? So uh, in this case, if we take all the numbers 0 1 0 1, okay, so 1 0 1, so here we are considering 4 bits, guys. Okay, at least 4 bits we are considering. So these would be 0, right? So because we have only 3 numbers, if we consider from here 1 0 and 1. Okay, so we are just putting 0 because 0 means no electricity or no current, right? So we can put 0. Okay, so what are actually these doing? 2 raised to the power 3, 2 power 2, 2 power 1, what are actually this one? If we consider any decimal number. Okay, so I'm just showing you, guys. uh, if we consider a decimal number here, okay, maybe like this one, uh, 10 square, maybe 10 square, and this is 10 to the power 1, and this is 10 to the power 0, guys. Okay, so let's just imagine things if you don't understand this. Okay, so let's say we have a number, right? 3400 and 40, 5, right? So here this 5 in 10th place value is 10 to the power 0 here. Okay, so we know 10 to the any number power to the 0 gives us 1, right? So 5 into 1 equal to 5 here. 5 into 1 equal to be 5, right? So 10, these 4 in this place, 10 has a place below of 1. Okay, so here 10 to the power 1 would be 10, right? So 4 into 10 would be 40 here, right? So 10 square, that means this in here 10's value is 100, right? So we'll have 100 equals to 400, guys, right? And here 10 cube, that means it has in this in here 10 has you know 1000. In this position 10 is like 1000, right? So 10 to the power 3, so 3 would be uh, okay, so here it would be 3000. Okay, so if you add all them, 3440 and 5, if you add all them, okay, so you will get 3400 uh, you know 45. Okay, so the same thing will be applied in binary as well. Okay, in our case. Okay, so 2 to the power 0 is 1. 2 to the power of 1 it could be 0. So here we're just having our values, right? So 0 1 0 1. Okay, so if we consider about the 3, so 3 divided by 2, so you understand this. Okay, 3 divided by 2, result is 1 and remainder is 1, right? 1 divided by 2, result is 0 and remainder is 1, right? Okay, so uh, we have 1 and 1 only. We have 1, and these two values will be, these two bits will be 0. Okay, we are just having them value 0, right? So for our AND operator, okay, for our AND operator, you see, for our this AND operator, what it will behave. Okay, so 1 and 1, these two, this 1 and 1 will give us 1. Okay, so when both of the bits has the value 1, then we will get 1. Otherwise all other things will give us 0, right? So both of them should be true, right? So 1 and 1 means true here. Okay, so in this case, 1 and 1 will give us 1. 1 and 0 will give us 0. 1 and 0 will give us 0. 0 and 0 give us 0. Okay, so we have the value 1 only. Okay, so here uh, we have a value of 1 only, right? Okay, so if we just do this one in this way, okay, like this, if we use OR operator here, what do you get? You see 7. So how actually does it work? Okay, so if we just show you guys, uh, okay, so for 5 we know these are the binary numbers. Okay, for 3 we know these are the binary numbers. Okay, we previous in the previous example we already seen, we have already seen this. Okay, so here we know for OR operator. Okay, so how actually it works? For OR operator, uh, only 0 and 0 gives us 0, and all other combination like 1 0 0 1, all other 1 1, all other combination gives us 1, right? 1 and 1 gives us 1, 0 and 1 gives us 1, 1 and 0 gives us 1, and 0 and 0 gives us 0. So add all the values. Okay, so 2 to the power 0 is 1. So when this bit is active, I mean this bit is 1, then we have 1 value here. Okay, so when this bit is active, so we have 2. Okay, 2 to the power 1 means 2, so 2 plus 1 would be 3, right? And when this bit is active as well, we have 4. 2 square, 2 square means 4, right? So 4 plus 2 plus 1, we have 7. So this is how we're getting the value 7, guys. Okay, so I hope you never saw this kind of a presentation. I hope this video will be really helpful for you guys. Okay, for XOR operation. Okay, this is XOR operation. So what does this actually mean? Okay, so this means if you see here 1 and 1, right? 1 and 1, this is exclusive OR, guys. Okay, so what does exclusive OR mean? Exclusive OR means 1 and 1, all the same bit. Okay, when it's 0 and 0, it will give 0. When it's 1 and 1, it will give 0. When it's 0 and 1, 1 and 0, this will give 1. Okay, it's exclusive OR, guys. What does OR mean? OR means two different. Okay, this or this. So when both of the bits are same, 1 and 1, 0 and 0, so this is not exclusive OR. Okay, so 1 and 1 gives us 0, 0 and 1 gives us 1, 1 and 0, here we're getting 1, right? And 0 and 0 gives us 0. So which bits are active here? This bit and this bit, right? So value of these are 2 and 4. Okay, so 2 and 4 are 6, guys. So if we provide this sign here, so what do we get? You see, we get 6, right? So this is how XOR operation works, guys. Okay, guys, this video is getting a little bit longer. So in the next video, we will discuss about left shift, right shift, and other operator, right? So thank you for watching this video. See you in the next video.